I had held roles in manufacturing engineering with BMW, then 20 years with Langer Construction, developing their off-site manufacturing business. Today I'm going to discuss a bit more about forward thinking, somewhat different to the presentations earlier. I'll come across from a supplier's perspective. And I would like to talk about DfMA, Design for Manufacture and Assembly, and share with you a case study where some of the benefits of DfMA were deployed. So a bit of our audience participation here, if you don't mind. So, show of hands. Who likes to do things twice? Who likes to do things that cost too much, that take too much time and too much energy? No? Oh, we're up to a good start then. Best way you can predict the future is probably to help create it. So what does that mean in practice? What does that mean for us? And how can we actually help ourselves to create the future in the building industry? One way we can do this is to adopt an initiative which helps manufacturing, which helps transporters, which helps the installation crew. Beg your pardon. There we go. One of these things is Design for Manufacturing and Assembly, which does help the manufacturing chain, installers, the transporters, the world around. So Design for Manufacture focuses on two methodologies, design for the manufacturing supply chain and also design for assembly, the installer at the site. I think there's probably a third one I would mention here, which is design for transportation as well. I think it's important that you take into consideration the loads, the weights, the masses, the site access, the temporary works requirements in order to deliver the off-site manufactured goods. Just touching on some of the benefits of DfMA, you can expect productivity both at the manufacturer, both at the other site as well. There's reduced manpower and arguably a safer site. You can expect better quality, accelerated programs, although it does have its challenges, of course. If you look at off-site manufacturing or modern method of construction, you look at the costs in isolation without the holistical benefits. It somewhat carries a different story, so you need to understand the full picture. Touch on the technologies there in construction where DfMA is deployed. So we're looking at volumetric construction, bathroom pods, CLT, which we'll come on to in a moment, advanced precast concrete, steel, and also MAP systems. With CLT, it's part of a family of the mass timber products. So we've all heard of GLT. Engineered cross-laminate timber, typically floors, walls and staircase, which we'll discuss in a moment, and LVL for beams and other structural purposes. First thing I'll say first is get to know your supply chain, understand what their capabilities are, understand what sizes, what shapes, what weights that they manufacture. Examples being at XLam, we manufacture panels which are 3.4 metres wide, up to 16 metres long, ranging from a 90mm thick up to 310. I think outside of those dimensions, outside of those constraints, you're looking at either something that can't be manufactured or something that's going to be expensive. What I will say is pretty much the machinery dictates what size and shapes that you will get. So just staying with the manufacturer just for this last slide, important to know the whole process. Keep it simple. Radius edges on cutouts would be very, very advantageous for us. Sorry, I'm juggling a couple of slides here. We have got 5-axis machinery there at our manufacturing facility, but it doesn't mean that we can do everything, so it does have its limitations. You can consider pre-assembly of components, but I think the important message I want to leave with you today is start speaking to the supply chain early, start speaking to the fabricator early. Okay, so I'll move on to the main presentation. Is the fantastic case study of the Iron Creek Bay Farm Stay. This is at Sorell, Tasmania. The vision of the local developer. It was only made possible through the collaboration of Michaud Associates with XLam and Stanstruct as the installer. Touching on some of the drivers about the site, The site was zoned as significant agricultural use. The developer wanted to diversify in what he was doing there, and he wanted to take advantage of some of the more growing and local regional market by putting accommodation on his site. The top drivers there that was driven to the project was carbon storage and capture, biophilic benefits, speed of construction, and waste minimisation. The building designs and the built form complemented the nature and the timbers surrounding the site. The buildings were kept very, very low to mimic the actual contour of the site as well. The site did have some challenges. I think it's fair to say there was a skilled labour shortage, minimised access to traditional materials. There was undulating site conditions with differential materials. Inclement weather at the inlet also proposed a problem. Looking at the site, so you have 19 buildings in total, 15 of the 3 and 5 bed pavilion units, 3 backpacker buildings, and a 2-storey restaurant and cellar door. So starting with the holiday pavilions, there was 15 pavilions with private balconies, all with private views of each window in the pavilion. You can see there the jagged shape afforded the windows unrestricted views of the water, and there was no possibility for the neighbouring building to look into or to look onto and to the building beside it. They wanted exposed timbers and a natural feel, and they wanted those timbers to be kind of unrestricted throughout on the soffits as well. So how do we go about designing and getting the best result both for the client and everybody associated with the project? So it was the combination of the architect, who was very, very passionate. Michaud was driving this with all his heart. Nick Hewson, for those who know Nick, had a tenacious appetite for making the best of this project. The engineer was also an XLam employee with Nick. Suppliers, ourselves, the transporter Monsons, and also the installer who we have today with just Chris Wood across the back. They all form the nucleus of this collaboration. So there's a brainstorming session which went through many kind of iterations, is to the best way to procure this, the best way to build this, and the best way to effectively transport it before that. So they looked at multiple options. They looked at thickening the slabs up, looked at thinning the slabs down, looked at minimising the actual components. The installer, fair to say, had carried a crew with living away from home allowances, so the installation time was also kind of critical and very sensitive. We looked at part assembly of the components prior to getting to the site, and we also looked at what other prefabricated elements we could get in, including bathroom pods, as you'll see later. So, short video here. What happened in the end was we chose a thicker floor slab, and it enabled us to span from the north to the south on the frame. It created less components for us to lift. There was less fixings to put in place. The thicker slab also gave the access to the balcony, the cantilever balcony on the front as well. The path in the foreground that you'll see was specifically designed to take the 32-ton crane that's loading the parts there, and it was a service road for all of the deliveries, which was one way, which controlled the traffic on site to minimise the health and safety implications. For those that can look at that crane, will probably notice that it's sitting nicely between the buildings. That was because the building, the space between the buildings was specifically designed to suit a 32-ton crane, such that it could sit between the buildings, load the components to either side, without having to move to the next one. So, nice feature about that. Some of the DfMA initiatives, you'll see there it's bright red. That wasn't because it was the final colour. That was the pre-clad vapour barriers, which XLam fitted at the factory. Looking closer and further on, the materials which the panels were delivered with were typically a 20mm batten. they used those 20mm battens all over the application. So they used the 20mm on the wall panels as part of the actual cladding system, and some of the other dunnage was used as a temporary fall arrest system, which you can see there on the front. So a couple of things there is the saved costs by reusing materials and then minimise the waste. Next one is to get you the clear access and unfettered views to the water, so no beams on the soffit beneath. They placed beams on the roof here, so I give it a nice clean soffit finish. Next one was Hickory's first bathroom pods that were installed with CLT. So I'll come on to some of the lessons learned later, because it didn't go without one or two implications. The other thing as well is there was plenty of cut-offs both in the windows and the doors, and they were recycled and reused for some of the furniture, as you'll see in this picture here. So there was a tremendous cost saving, but also it avoided waste minimisation, minimised waste on the site. The screw types which we used in these buildings, we rationalised the screw type. I think there was only 6 screw types in total, whereas usually on a build like this there's about 12. What that does, it creates less complications for the installer. It's an easier thing to procure and to store. Starting off with the concept, that's how it was expected to look. That's how it ended up looking. So just a summary there on the pavilions. It took approximately 5 days per pavilion. The prelims were limited to the crew, the crane, the props, and the screw guns. Crew members totaled up to 6, including the crane. I think, Chris might want to speak later, but there's 15 of these buildings. It's important that we nailed down all of the efficiencies as early as we possibly could, because it would be effectively rolled onto 15 of these pavilions if we didn't. Moving on to the backpacker buildings, there's 3 of these. They're accommodating for all budgets. I think if anybody wants to stay there, it's approximately $120 a night. But what you can be assured of is you got a private room, and you'll get natural materials. And that was the narrative going through, is that the nature surrounding this unit wanted to be carried forward within. Much like the pavilions beforehand, there was a collaboration looking at the types of materials, but also the sizes and geometry of materials and where you could use different materials. So, you'll see on this one, it was determined that CLT would be used for the floors, the walls, and the roof. There's a cantilevered section, as you'll see there, at the ends there, which was supported by an LVL structure, which enabled better views and vistas to the water. The next initiative, which was quite significant, the original design used a pitch of a roof, which meant that the width of the panel was effectively wider than what could be manufactured at XLam. So by reducing the pitch of the roof by just 1 degree, it brought it within the maximum width, which was 3.45 metres. So what that meant is, instead of 3 panels, you'd only need 1 panel. And what the benefit was to the site was that you took 2 days off each of the backpacking units in terms of installation. Another initiative is, you'll see the window reveals, nice architectural feature there. It was previously budgeted for, but then there was the cut-offs for the doors and also the windows, which again, they were recycled and they were put into use there. So there was a saving of approximately $100,000 of material costs. But in addition to that, would have been waste otherwise to remove them from the site. Concept and the reality. I think typical of backpackers, the lady in the picture beforehand was there for 24 hours, but not again for this one. So just summarising the backpacker buildings, 1 week to install the first building with efficiencies and learnings. The second and third installation was a bit quicker at 3 days. Construction prelims were the same, limited to crew, crane, props, and only screw guns. Made for a very quiet site, made for a very safe site, very clean site. Again, same crew members managed to do the builds, 6 in total. So moving on to the star of the show, the restaurant and cellar door. Restaurant and cafe on the second level. We wanted unrestricted views to the water, maximum exposure of the natural materials to take in the surroundings, but above all, they wanted a dramatic experience for the diners and for the people that were visiting the area. This is how the roof was going to look. So a coffered system was proposed. It did have over 600 components. When we looked at this as a collective, it's going to be very expensive to manufacture, very expensive to install, and even more expensive to transporting a lot of fresh air there. Certainly too complex, so we needed to move on to a new solution. So the new solution was a vaulted roof solution. Roof was considered as one plate rather than individual components. We did maximise the panel width, which dictated the pitch of the roof. So the panel width was 3.45 metres. The panel, as you can see in the image there, it spanned 13.5 metres in total, 4.5 metres of which was over the balcony. No columns, as you can see on the balcony there. What else was a benefit of this roof design was that there was now suddenly more north-facing planes than there was before that. So quickly jump onto the opportunity that was afforded and put PV panels onto the roof, of which they managed to squeeze 320. Generating 100 kilowatts, which was matched by an equivalent battery system. All of the timbers that were external at the lower levels were Hein GLT, and which were H3 treated. Next thing we looked at was rationalising the design of the fixings. It didn't have an FRL, no requirement to embed the fixings, didn't need to be anything special. Chosen, seized upon the opportunity to try and make advantage of the rudimentary nature and the agricultural use of the surroundings by exposing these fixtures. So they are simply kind of galvanised fixings, which I think adds a nice feature to this concept and reality. So just summarising the restaurant, it took 6 weeks to build the whole structure. Chris and his team managed to erect the roof in 4 days, and that was the reason it was 4 days. They did it over a weekend because the COVID restrictions were announced, and these guys need to get back on the plane, so they did all they can to erect that whole structure in 4 days. For anybody that knows Nick Hewson, industry mass timber engineer, he said it's one of the coolest things he's ever designed. He said it was more efficient to manufacture, more efficient to build and transport. It offered the solar power performance. Some of the other features that the windows, the window supplier was happy to take the dimensions which were on the model and the drawings. Didn't need to actually do any on-site measurements. He had the confidence that there was the geometry and accuracy from the previous buildings on the site. But there were lessons learned. Everything didn't go always to plan. Looking at the pavilion roof, the original design was to have a single wall panel, which then projected above the roof to create the parapet wall. In actual fact, what happened, there was quite a lot of angles coming into play there. There was deflection in the slab, and what it meant was that when you mated the different panels up to one another, there was gaps and there was mitre cuts to overcome. I think going back in time, if we could, you would probably consider these as several parts. You do more of a platform system, build the wall up, roof across the top, and then you create the parapets separately. Talking about bathroom pods, with it being the first experience with hickory, of putting bathroom pods into CLT, didn't quite go to plan. A couple of issues there. The fitted pipework didn't quite align to the penetrations in the CLT. CLT penetrations were taken from the bin model, which was very, very accurate, but unfortunately the pipework at the bathroom pod manufacturer wasn't quite as accurate, so the pairs didn't line up. I think what we would do is to consider larger penetrations next time, or we'd consider cutting them at on site. Quite a big one, this. The value of the panels when they mated together, it was always going to be on shore. It's somewhat of an architectural striking piece, but it was very, very difficult in terms of mating the two panels together. It relied heavily upon the accuracy of the supporting structure. The panel edges were razor sharp, so when you moved quite a cumbersome, heavy 3.5 metre panel in to one another, very difficult to manoeuvre, very sharp edges. So I think the next steps, or the next time we would do this, would be to allow more tolerance in the supporting structure. You possibly round the edge or rebate the edge to create a shadow gap joint, and develop a capping piece to put over the top. Just a summary on the development. Concept design finalised 2018 there. DA award is shortly afterwards in August 2018. The construction programme ran from 2019 right over to December 2021. Somewhat hindered by COVID restrictions, albeit they managed to keep the site running, but they had to actually go through quite a lot of protocols and extremes to abide by the COVID restriction requirements. It eventually became operational by April 2022. The next few slides are images of the completed development. So no columns there, view to the water, vaulted ceilings. So flying over the pavilions, the backpackers on the left, agricultural use throughout the farm there, coming up to the restaurant and cellar door. So the solar panels would have been working nicely on a day like this. I'll quickly jump to the next one in case we're crashing the field. Okay, so looking at the case, the base case and the summary of this, when we started to look at this in its traditional form, it was expected or estimated to be around about $13 million. Putting the off-site manufacturing slant onto it, 8.7, so a significant saving. But the DfMA initiatives it was just been going through there enabled a further $2 million to be trimmed off than that. So those $1.5 million reduced from the timber costs from the original pricing, of which $1 million was a saving from the roof structure in the restaurant, $200,000 on window reveals and the production of furniture, and then 80,000 material reduce and mitigated disposal costs, and then fixing savings and so on and so forth to make up the 1.5 million. Approximately $500,000 in saving of the installation crew and the prelims associated with that. 2 months we're taking off the construction programme for the structure just alone. Just over 1,100 tonnes of sequestered CO2, approximately 5.75 hours to regrow that amount of timber. My closing thoughts, hopefully I've demonstrated there that if you invest in that and it's done properly, DfMA will improve the quality, save costs, reduce time spent on site, etc. I think early engagement and collaboration with the supply chain is key to the success of that. Be flexible when exploring the design options. I think don't be afraid to make big changes. This is what I took from Nick. Building it virtually, very, very good, but don't necessarily assume that everything works, as we saw with the bathroom pods. And finally, DfMA doesn't just happen by itself. It needs passion, it needs commitment, and we had abundance of that through Miso, thankfully. So it's important to identify the internal stakeholders. So the final part is get out there and find your champions.